Lesson 70 is going to cover similar space figures with area and volume. We've done some things with similar figures and corresponding side lengths. So we'll take it a little bit step further using some different geometric shapes. Basically similar figures as talked about, we have to have corresponding side lengths have to be in proportion, meaning they have the same ratio. So 5 in figure A would correspond with 35 in figure B. That's why we have 5 over 35. 10 corresponds with 70, 10 and 70, and we have 5 corresponding with 35. So all of those ratios would reduce to 1/7. So that would be our scale factor, 1/7. And in this case, it's basically 1 foot in figure A is equivalent to 7 feet in figure B. So I'll start you off here in example 1. I think it's easiest to go ahead and name these figures. I'll say A and B again. In A and B, all my side lengths are going to be as a numerator, and B would be my denominator. So I look at this, I start off with 28 over 14. 28 in figure A, 14 in figure B. Both of those would reduce to 2 over 1. Again, this is a ratio, so we'd like to have a numerator and denominator. So 2 centimeters to 1 centimeter, basically. We also need to compare 12 to 6 to make sure that they are similar. 12 over 6 again reduces to 2 over 1, so these would be similar. B, same scenario. The only thing that you need to be careful is here is making sure that you're comparing apples to apples, not apples to oranges. What I mean by that is 100 is talking about a diameter and 30 is talking about a radius. So you'll need to convert either to diameter or convert to radius. So in A, I'm going to start you off by 50 and 20. This is figure A. Here's figure B. Figure A, 50 corresponds with 20. 50 over 20 would reduce to 5 halves. In the second part, again, I need to do a conversion here. In this conversion, I cannot use 130. So what I would need to do is convert one of them. I'm going to go ahead and convert this 30 right now to a diameter, which would give me 60. So I would have 100 over 60, which would reduce to 5/3. And as you notice, 5 halves and 5/3 are not the same. Therefore, these figures would not be similar. Along with similar figures, we can also determine things are similar based upon surface area or area and volume. The big thing here is when you're dealing with surface area, you cannot use A to B. Surface area is squared, so we're going to use A squared and B squared for area measurements. For volume, we're not going to use AB. Again, AB is just a side length. We're going to use A cubed, B cubed, because volume is cubed. So the directions have us for each of the figures is similar. Use the information given to find the scale factor. We want to find the scale factor, which would be A to B, of the figure on the left to the figure on the right. So left over right. Again, A over B. When we have A over B here, this is cubed, A cubed, B cubed. Why is it cubed? Well, our measurements are cubed. They're dealing with volume. So A is on top, B is on the bottom, which means we'd have 112 over 896. Next thing I would want to do is go ahead and reduce that fraction. They're both even, so I know they're going to reduce. And in the end, they're going to reduce to 1/8. Now, 1/8 is the volume ratio. Remember, this right here is being cubed. Okay, to get rid of a cube, you are going to use a cube root. And again, that states that above. To get rid of a cube, use a cube root. The cube root in your calculator would look something similar to that if you're using one of mine in the classroom. Basically, you'd need to find the function x root right there. What you're going to do to put it into my calculator, you'd use 3 x root. Basically what they're doing is substituting the 3 in for the x, and then you could go ahead and solve it from there. Reminder, what a cube root is basically saying what number times what number times what number would give you that number. So I would break things down. This is really cube root of 1/8. The cube root of 1 is going to be 1. The cube root of 8 is going to be 2, because 2 times 2 times 2 would give us 8. So the cube root there, after we work through it, we would get 1/2. And 1/2 would be our scale factor. Okay, 1 to 2 for basically side measurement. Slightly different in example 4. Again, name your figures. We'd have A and B. The thing that we'd want to note here is that our surface area is going to be squared, so units squared when you're dealing with surface area. So now we'd have A squared over B squared versus A cubed over B cubed. We're using that because the measurements given are dealing with area. So I'll go ahead and put the area down, 12 over 147. Next thing I would want to do is go ahead and reduce that fraction. That fraction will reduce to 4/49. Remember now, this is squared. We want to get the scale factor, so we need to get rid of a square. To get rid of a square, we're going to go ahead and use the square root, and we've dealt with square root a lot this year. So the square root of 4 is 2. The square root of 49 would be 7, and that would be our scale factor in example 4. Example 5, for the figures given, you're going to use the scale factor again from left to right, and you're going to find the ratios of surface area and the ratios for volume. So the first thing, again, name them A, B. Our scale factor that we would want to find here, dealing with the information given, we're given side lengths or radiuses and diameters, and we would want to go ahead and find the scale factor of these similar figures. I'm going to go ahead and use 12 and 6 here. The reason why I'm using 12 and 6 is then I don't have to do any conversion, as those you're given a diameter and a radius. So 12 over 6, the scale factor, the side lengths would be at 2 to 1, so 2 meters to 1 meter. We'd have to find the area. Now area is A squared, B squared. What you have here is A and B. So basically what we need to do here is take those and square your numerator and square your denominator. So you'd have 2 squared over 1 squared. Your area ratio would be 4 to 1. Volume, same process. However, we are going to cube things. So we have A cubed, B cubed. Again, what I would take is my scale factor, 2 over 1, and I would cube those. So I'd have 2 cubed over 1 cubed. The volume ratio would be 8 to 1. Last example here, I'd like you to go ahead and try it on your own. So go ahead and pause the video, do your conversions of scale factor, and notice again in example 6 they have all side lengths, so you're finding the scale factor initially and converting your area and volume ratios. So pause the video and give her a shot. Alright, now that we're back here, knowing these figures are similar as stated in the directions I used 4 and 24, that converted to 1/6. Next thing I would do is find my area. Again, by squaring my scale factor ratio of 1/6, I come up with 1/36. Find my volume. Take my scale factor and cube them. And I would come up with a scale factor of 1 over 216. This will conclude lesson 70.